All right, so today we're going to be reviewing for our progress check. So what are we going to be learning today? So we're going to be talking about rigid transformations. So we're going to be talking about translations, reflections, and rotations. And just keep in mind all rigid transformations, they preserve congruence. So another thing that we're going to be looking at today are congruence criterias. So they're the 5 criterias that you should be familiar with. Side, 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 angle, side, angle, angle, side, and hypotenuse leg. And just keep in mind that the criterias are the same backwards as they are frontwards. So side, angle is the same thing as angle, side. And then when we're done, we're going to wrap everything up. And then if you folks are in my class, please remember to send all emails to my .org address. So the first thing we're going to be looking at are translations. All right, so when we talk about translations, we're talking about just simply moving an object vertically or horizontally. And this is our general rule for translations. So in this example right here, we're asked to translate this object 3 units down and 5 units right, and we're going to write the rule out. So the first thing you want to do when doing any of these problems, and this is going to be a pattern that I'm going to keep throughout this video, and the first thing you want to do for these type of problems when you're asked to transform an object or objects is to write the rule that you're going to use first. So here I have my rule written out. Because I'm translating 5 units right, I add 5 to the first coordinate, and because I'm translating 3 units down, I subtract 3 from the second coordinate. And the next thing I want to do is apply that rule to each point. So I write the coordinates out of h, I, and j, and then add 5 to all of the first coordinates, and then subtract 3 to all of the second coordinates. So as you can see, I took -2 plus 5 to get 3, and then I subtracted 3 from 1 to get -2. And I repeat that process for all of the points on my geometric object. And then the last thing you want to do is to plot the points. So here are my points, my new points for my image. And keep in mind, you want to use your apostrophes. That'll let the reader know that this is the image and this is the pre-image. So visually, this is what the translation looks like. And that's your answer for this problem. So what if we're asked to work in reverse? So what I mean by that is if we're asked to identify the transformation to get our image, we want to write the coordinate rule / coordinate notation. So when I say coordinate rule, it means the same thing as coordinate notation. So we want to make an assumption about which transformation was used here. And here the orientation is exactly the same for both of these figures. And the order of the letters is also consistent. So I have H, I, J, H prime, I prime, J prime. So I'm just going to assume it was a translation. The next thing you want to do is you want to write out both the coordinates of both figures and identify a pattern. So here, if I take a look at my pre-image and I take a look at the coordinates and compare it to my image coordinates, you'll notice that each first coordinate from each point had 5 subtracted from it, and each second coordinate had 4 subtracted from it. And you have to remember that when you're looking for a pattern, the patterns have to be consistent for every single point. Not just 2 of the 3 points or not just 3 of the 4 points, but they have to be consistent for all of the points. If they're not consistent, then obviously you need to look for another rule. So since I've identified my rule, or excuse me, my pattern, I could go ahead and write out my rule. So here's my rule. So take each coordinate, we subtract 5 from it, and we take each second coordinate and then we add 4 to it. So the next thing that we're going to look at are reflections. So hopefully this should look familiar, and we were primarily just concerned about 4 types of reflections. There's infinitely many types of reflections, but we're only going to be looking at these 4. So the first one is a reflection over the x-axis. So as I load up these images, keep in mind that the pre-image is going to be in teal. So this is basically the original image, and you can see it was reflected over the x-axis. And then we have a reflection over the y-axis. And then we have a reflection over y equals x. And then a reflection over y equals negative x. So keep in mind the rules right here. So if you take a look at all 4 rules, you folks should be familiar with these rules by now. You've done it often enough where you could quickly identify which reflection took place. So let's take a look at this example. Suppose we want to reflect this object over the line y equals x. So we're going to follow that 3-step process. We want to write the rule that we're going to use. And then we apply the rule to all of the points. So I take h, I, and j. And here my rule says I just simply swap the coordinates. So that's exactly what I'm going to do for my image coordinates. And then I just simply plot the points. That'll give me my triangle. Now, here's something optional. You can draw the line of reflection to help you visualize. I personally, I'm not going to require it, but some students feel it might help them. So that's always something that you can do. So let's take a look at a reflection example in reverse. So we want to determine a transformation that was used to obtain the image. So I want to know, how did I get this image from this pre-image? So again, we're just going to follow the same process as we did before. We want to make an assumption about which transformation was used. And here it seems pretty logical to assume that a reflection was used. So we're going to label both sets of points, identify the coordinates for both the pre-image and the image, and see if we could identify a pattern. So if we take a look here, notice the pattern was that the second coordinate had their signs change. And because of that, we know that this is a reflection over the x-axis, as you can see by this diagram right here. So now we're going to be looking at counterclockwise rotations, and they're all going to be about the origin. So those are only rotations that we're going to be concerned about. And these are the 3 main rotations that we've been talking about this quarter. So 90 degree, 180 degree, and 270 degree counterclockwise rotations about the origin. So again, if you take a look here, notice that here's our pre-image, and for the subsequent pictures that I'm going to show you, the images are going to be in teal. So if we take a look at our pre-image here, I rotate this 90 degrees counterclockwise. So one of the ways you can help yourself visualize, how rotation works is, notice I'm in the second quadrant for my pre-image. And if I rotate it 90 degrees counterclockwise, it's going to end up in the next quadrant. So that's a good way to help you basically check your work to see if you're ever unsure. You should be able to at least identify which quadrant will my pre-image end up in if I rotate it a certain number of degrees. So if I rotate it 180 degrees, notice my image ends up in the 4th quadrant. And then if I rotate it 270 degrees, it ends up in the 1st quadrant. So again, 90, 180, and then 270. So you'll notice 90, 180, 270. So kind of like a good way to remember how the rotations work. Just think about which quadrant your image is going to end up at. Okay, so let's say, for example, I want to rotate the following geometric object 270 degrees counterclockwise. So just like before, write your rule out. And here, like I mentioned earlier, know which quadrant your object is going to end up at, or know which which quadrant your points are going to end up at. So for instance, my triangle here is in the first quadrant. So if I rotate it 270 degrees counterclockwise, I would get 90, 180, and 270 degrees. So when I'm done, if I did everything correctly, I should have my image in the fourth quadrant over here. So again, we want to apply the rule to each point. So I list out my coordinates h, I, and j, and then I simply apply the rule. So if we take a look at the rule says we swap the coordinates and then change the sign of the second number, which is what I have here. So I swap the coordinates, and then I change the sign of the second number, and then I just simply plot my new image. And there you have it. So now we're going to be talking about a series of transformations. So for this class, we're only going to be looking at 2 transformations, but keep in mind, you could do an infinite number of different transformations, but we're only going to be looking at 2 at a time. So let's say, for instance, I want to take this triangle and rotate it 180 degrees about the origin. Then I want to translate it 1 unit left and 1 unit down. So just like before, you want to write your first rule. Write the rule that you're going to use first. This is my recommendation to you. Your teacher might have something different, but I like to work with rules one at a time. So write your rule that you're going to use first, which is a 180-degree rotation. And then you're going to apply that first rule to each point. So I take Hij, and then I apply the rule to each point. So if I take a look at the rule, I'm just simply switching the signs of my first and my second coordinates, which is what I've done here. And then we want to plot our first image, which is what I have down here on my coordinate grid. Now we're going to apply the second rule. So you want to write your second rule out, right? So just write the general rule for a translation, 1 unit left, 1 unit down. And then take your first image coordinates and apply that rule. So you're going to take your first image coordinates and apply the second rule. So notice what I have here. I have my h prime, I prime, j prime. And then I subtract 1 from all the first coordinates, subtract 1 from all the second coordinates, and I end up with h double prime, I double prime, j double prime. And now I could simply plot my second / final image. And this is what I have in purple. And just let me remove this red image. And this is what your final transformation will look like. So it helps if you work with one transformation at a time, because if you try to do it in your head, it could be a little bit difficult. So I would highly suggest working one transformation at a time. Sure, it might take a little bit longer, but you're going to be correct. So you have nothing to lose. So let's say I want to work in reverse. I want to identify, what series of transformations got me this final image right here from my pre-image. So how did I get from here to here? So I want to write down 2 plausible transformations. So I know the orientation is different, so it would be logical to assume that a rotation happened. And because I went from the first to the second quadrant, a 90-degree counterclockwise rotation occurred. So that's reasonable to assume. And I would probably also assume that a translation occurred as well. So I want to think about, okay, which rule do I think was applied first? And sometimes, this could be a little bit of a guessing game, but you have a 50-50 chance of getting it right the first time. So personally for me, because, I tend to think, spatially and visually, I know that a 90-degree rotation occurred first. So here I'm going to write out my rule for a 90-degree counterclockwise rotation. And then I'm going to try to apply the first transformation to the pre-image coordinates. So what I did right here was I took my pre-image coordinates and then I applied the first transformation, which was a 90-degree counterclockwise rotation. So I'm going to go ahead and plot that right there. So it looks like I'm on the right track. And here, as you can see from my graph, it looks like the second transformation was a translation 1 unit down. So here, that would be my 2 transformations to get me my final image. So my 2 transformations that occurred were first a 90-degree counterclockwise rotation about the origin, and then a translation 1 unit down. So what are the 3 steps to performing a transformation? So these are like the kind of general rules. So if I ask you to take this geometric object and then perform a translation, a rotation, a reflection, or any combination of those 3, the first thing you want to do is write your rule. Know your rule and write it out. And then you want to apply the rule to each point. And then you want to plot your new point. So those are kind of like the 3 steps that I like to encourage students to do so that they're pretty much almost guaranteed to get their transformations done correctly. All right. Now, again, if you're not familiar with the transformation rules for translations, reflections, and rotations, you should go back and study these rules because they should be, at this point, they should be second nature by now. So the next part of our lesson that we're going to be looking at is triangle congruence. So what are the 5 congruence criteria? So we mentioned it earlier during the presentation. So side, side, side. And side, side, side occurs when 3 pairs of corresponding sides are congruent with each other. So here, notice the corresponding sides, all 3 of them are going to be congruent with each other. Our next congruence criteria is side angle side. So we have a pair of corresponding sides and their included angles that are congruent. So notice the included angles means the angles between the 2 sides. And the next one that we're going to be looking at is angle side angle. And it's 2 pairs of corresponding angles and their included sides that are going to be congruent. So again, if you take a look, we have two angles right here and the included side that are marked congruent. So we have 2 pairs of corresponding angles that are congruent and their corresponding included sides. And then the next one that we're going to be looking at is angle, angle, side. So we have a pair of corresponding angles and a pair of non-included sides that are congruent, which is what we have here. So we have angle, angle, side, angle, angle, side. So notice the side is not between the 2 angles. And then the last one that we're going to be looking at is hypotenuse leg. So it's a special case of side-side angle, or angle side-side if you prefer. So it's basically a pair of hypotenuses and a pair of legs that are going to be congruent. And this is the only case of side-side angle that will work for triangle congruence. So again, as long as you have 2 right triangles, then the only thing you need are a pair of hypotenuses and a pair of corresponding legs that are going to be congruent. And keep in mind, when I talk about hypotenuse, you know that I'm talking about a right triangle because only right triangles have hypotenuses. So here, let's look at some triangle congruence examples, and I want to determine, are these 2 triangles congruent, and if so, by which criteria? So you could probably just pause the video as I go over each example, see if you could guess one on your own, and then unpause the video and see if you're correct. So here, I want to see, are these 2 triangles going to be congruent? And you want to make sure that you're marking your diagram, right? Mark your diagram if needed. So here, I know that by the reflexive property, these 2 triangles, they share a common side dt. So notice I have 3 pairs of corresponding sides that are going to be congruent. So these two triangles are going to be congruent by side, side, side. So let's take a look at this next example. Are these two triangles congruent? So here I have vertical angles. And since I have vertical angles, these two angles are going to be congruent. And I have angle, side, angle, angle, side, angle. So these two triangles are going to be congruent. Now let's take a look at this diagram right here. Are these two triangles going to be congruent? And the answer is no. They're not going to be congruent, and here's why. You're probably thinking, well, I have angle, angle, side, angle, angle, side. But pay attention to the order. So I have one arc here, two arcs here, and a side. So I have 1, 2, side. But here I have 2, 1, side. So you'll notice that the order doesn't quite match up. So these two triangles cannot be concluded to be congruent. What about this diagram right here? Are these two triangles going to be congruent? So again, you want to make sure that you're marking the diagram. So I have a pair of vertical angles. All right. Now here I have angle, angle, side. Angle, angle, side. So these two triangles are going to be congruent to each other. Well, what about these two triangles? Are they going to be congruent? So make sure anytime you get an opportunity to mark your diagram, please do so. It will help you visualize. So if you take a look, I have side, angle, side, and I have side, angle, side. And that's one of my congruence criterias. All right. What about this diagram right here? Are these two triangles congruent? So I'm going to use the reflexive property, mark my triangles. And here, is there anything else that I can pick up? And it doesn't appear that I could pick up any more information about these two triangles. So I don't have enough information to conclude that these two triangles are congruent. So I only have side, side, and that's it. But side, side is not one of our congruence criterias. So let's take a look at the next diagram. Are these two triangles going to be congruent to each other? And the answer is yes, by hypotenuse leg. So notice I have two right angles. So I have two right triangles. So the only thing I need to look at are their hypotenuses and a pair of corresponding legs, and they both check out. So these two triangles are congruent. And now let's take a look at this last diagram right here. Are these two triangles going to be congruent? So here I have angle, side, side. And I have angle, side, side. And angle, side, side, or side, side angle is not one of our criteria. So here, these two triangles are not necessarily going to be congruent. So I cannot make that conclusion. So the next thing that we're going to be looking at is marking congruent triangles. So suppose triangle MLK is congruent to triangle STL. So I want to mark the diagram appropriately. And you're probably wondering, well, these don't look congruent. Well, I would say this. Don't look at the diagram and just go by your eyes. Go by the math. All right, if they're telling you that the two triangles are congruent, go with that. So not all diagrams are necessarily going to be drawn to scale. And keep in mind that these two triangles could probably be in a different orientation as well. So here, if I take a look, the first letter is M and the first letter is S over here. So I want to mark that M and I want to mark that S. So mark both of these with one arc. So here, since both of these have one arc, then they're going to be congruent. Same thing with L and T. So L on this triangle, and I'm going to mark it with two arcs, and a T on this triangle with two arcs. And then K and L. So K, I'm going to give 3 arcs. And then same thing with angle L on this right triangle right here. So here, how do we mark the sides? Well, here I have ML, those are the first two letters here, and ST, those are the first two letters. So ML and then ST, give those sides a tick mark. And then LK and TL, LK and then TL. And then lastly, I'll give MK 3 tick marks along with SL. So this is how we mark our triangles congruent. So follow the order of the letters. So if you follow the order of the letters, you can't go wrong. So here, let's say I give you a few markings, but it's missing a marking. So let's suppose that these two triangles are going to be congruent by side, angle, side. So notice that the angle is between the two sides. So I want to make sure that I want to mark that on my diagram. So here I have the angle between these two sides. And then here for angle H, I have this angle marked between the two sides. So here, again, just to reiterate, so take a look at side, angle, side. There's an angle between the two sides, and that'll pretty much tell you what to mark or what's missing in this case. Okay, so one of the things that you're going to be doing a lot of this year is combining algebra with geometry. They're very closely connected, almost synonymous with each other. All right, so let's suppose that triangle ABC is congruent to DEF. So because of that, I know that AB is going to be congruent to DE. And the reason why I'm comparing AB and DE is it's really two reasons. If I take a look right here, AB, those are the first two letters over here, and DE, those are the first two letters over here on this side of the congruent statement. And if I take a look at my diagram, it appears plausible that 3x minus 5 corresponds with x plus 6 over here. So that's why I set up my equation. And to solve for x pretty much becomes an algebra problem. So I'm going to add 5 to both sides. I get 3x equals x plus 11. And then I'm going to subtract x on both sides, and I end up with 2x equals 11. And dividing by 2 gives me 5.5. So I use 5.5 to substitute that in for the values of x. And that'll give me my corresponding side length. So I know AB and DE are going to be congruent to each other. So if I take a look at A, I substitute 5.5 in for x. 5.5 plus 6 gives me 11.5. And if I substitute for the rest of the x's, that'll give me 5.5 for CB and FE, and 9.5 for AC and DF. So in summary, what did we learn today? So we talked about rigid transformations, translations, reflections, rotations. You want to be sure that you're remembering the rules. That to me is really the key thing to understanding translations, reflections, and rotations. It's going to save you a lot of headaches in the future. And the next thing that we learned earlier today were congruence criterias. So side, 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 side angle, side angle, side angle, 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 side, and hypotenuse leg. I didn't go through all of the specific problems because I didn't want to make this video an hour long. It's already running on, what, 29 minutes now almost? So again, all of the principles that I spoke about earlier, they can pretty much be applied to any problem. So if you need any extra help, email your teachers or see them during Zoom. Personally, for me, I'm available every single day from 2:45 to 3:15 after school, or during lunch from 12 o'clock to from 11:15 to 12 o'clock. And again, there's my email address if you need anything from me.